Guys, we're going to start your last notes for topic 2, and this one is on scale. It's going to be very similar to what we did yesterday because you solve scale in a very similar way that you would solve proportions. And so I can show you what I mean on the second page, but let's go ahead and get started on the first page. Okay, let's start with the definition of scale. It says the definition of scale is the ratio of the length, size in a drawing or model to the length, size of the real thing. So it's always the drawing or model over the real thing. A scale drawing is just an enlarged or a reduced drawing of an object that is proportional to the actual object. For example, you normally hear about a map. So if you look at a map, the distance from Ohio to Florida is, just a couple inches on a map, but in real life, or the actual distance is miles and miles and miles. So that's a scale drawing example. We use scale factors to help figure out the actual distance. Okay, so scale factor is the ratio that is comparing the drawing to the real thing, but it's always written in fraction form. Okay? All right, so then if we go down and we look at this example here, you will see that there is the scale factor of triangle ABC to the triangle DEF is 2. Because if you look at the number 8 to the number 16, from the scale factor to the actual factor, or from ABC to DEF, from 8 to 16 is multiplied by 2. And if you do the same thing from 9 to 18, multiplied by 2. 6 to 12, multiplied by 2. So the scale factor is 2. Versus if you look at this triangle over here, it says B is equal to 15, and then B is equal to 10. Okay, so if I go from 10 centimeters over 15 centimeters, it was 2 centimeters to 3 centimeters, which is the scale factor of 2/3, or 2 to 3. Okay, so finding a scale factor, you first want to write a ratio with the values, one number from the scale drawing and one number from the actual object. So be careful about the order and read the problem carefully. You want to put the first shape or the initial starting value on the bottom, and then put the second shape or the ending value on top. That's why in this example up here, you'll see the first shape was the triangle, or the initial value is on bottom, or 15, and the ending value, or what we ended up with, is on top. Okay, that's how we got the scale factor of 2 to 3. Okay, so whatever you are being asked to find, the scale for goes on the top, and then this should be part of the question. Okay, so let's go ahead and practice. All right, let's go ahead and practice these 2 questions. It says, a photograph is 5 inches long and 7 inches wide. It is blown up to make a poster that is 27.5 inches long. What is the scale factor, or what scale factor was used to make this poster? Okay, so what we start off with is on bottom, which is the photo, and we ended up with the poster. Now, if you look at the information given to us, they give us the length and the width of the photograph, but they only give us the length of the poster, which means we can only use the length numbers to help us figure out the scale drawing. So the poster is 27.5 inches over 5 inches. Okay, now it's a decimal and a fraction, so I'm going to go ahead and solve that by dividing and do 27.5 divided by 5 to get the actual scale. So when I do that, I know 5 can go into 27 5 times, which is 25. Bring up your decimal, bring down your last number, which is 25, and I know 5 can go into it exactly that many times. So your scale factor in this case is 5.5. Okay, so let's do number 2. In real life, Cincinnati and Chicago are 300 miles apart. On a map, They are only 6 centimeters apart. What scale factor was used to make the map? Okay, so we know that the map is what we ended up with. So that's on top. And then the actual distance or real life is on bottom. So I'll put actual. Another way that you can look at it is always just scale over actual is always going to help you in all of your problems. Okay, so I have the map over the actual distance. In that case, it's going to be 6 centimeters over your 300 miles. Okay, now when we solve this, we can just simplify it because it's written in fraction form. I know that 6 can go into both of these. So when I divide these both by 6, my scale factor is 1 centimeter represents 50 miles. All right. Okay, so let's go ahead and go on to the second page. If we go on to the second page here, we're going to practice solving scale drawing problems. And this is my first time using it where I can zoom in. So let's see if I can actually get it to zoom in. Okay, so it says first we need to set up a proportion. Okay, after we set up the proportion, you will then use that. Your first ratio should be created by using the scale they've given us. Okay, your second ratio should be created with a variable in the unknown piece of information. Okay, and then just like yesterday, you're going to solve a proportion by cross multiplying. So you cross multiply and then divide. Okay, so let's go ahead and practice these problems, and then you guys should be good to go for the activity today. All right, here we go. Nope, that's not it either. Oh, you guys. Awesome. Nope. Goodness gracious. Okay. Let's do the first two problems. It says the scale for a model house is 2 inches is equal to 3 feet. The real house is 21 feet long. How long will the model need to be? Okay, so for the scale over actual, so scale over actual, they tell us that it is 2 inches to 3 feet. That's the information they've given us. They give us the scale. They said the real house is 21 feet. So when I set this up, 21 feet is going to be on bottom, and it's so important to use your units to help you solve this, and X is on top. So when I solve this problem, I'm going to cross multiply and then divide. So to cross multiply and divide, I'm going to do 21 times 2, and then I will have to divide by 3. So 21 times 2 is 42. And then I'll have to divide by 3 in order to figure out my next value. So my scale drawing will be 14 inches. On a map for number 2, the scale is 1 centimeter represents 150 miles. It says if the distance between 2 cities on the map is 3 centimeters, find the actual distance in miles. So for scale to actual, my proportion will be set up as 1 centimeter over 150 miles. Okay. Then they say that on the map between 2 cities, it's 2 centimeters. So 3 centimeters. So the 3 centimeters has to go on top because centimeters is on top, and I'm trying to find the actual distance. So in order to solve this, I will have to cross multiply and then divide. So I will do 150 times 3 and then divide by 1. 150 times 3 is 450, and then 450 divided by 1 just gives me a value of 450. So the actual distance, if it's 3 centimeters long, is 450 miles. Okay, last part. It says a state's driver's manual shows a scale drawing of a rectangle parking sign. The sign or the scale used is 1 centimeter is equal to 0.5 feet. What is the area of the actual sign? Well, in order to find area is equal to length times width. So that means we need to find the actual length and the actual width in order to find the area of the sign. Okay, so I'm going to do 2 separate problems here in order to find the area. Okay, so let's start off with the height, okay, or the length. Okay, so here is the height. Okay, when I solve just the height, I'm going to use the same scale that they gave us to use, the scale over actual. They said 1 inch represents 0.5 feet. Okay, if I look over at the height of this sign, it says that it is 3 inches. So, or I'm sorry, 3 inches. So 3 inches is going to go on top, while X is going to go on bottom because I'm trying to figure out the actual height of this sign. Okay, I'm still going to cross multiply and divide to help me solve this. So when I cross multiply and divide, I'm going to do 0.5 times 3, and then I'm going to have to divide by 1. When I do 0.5 times 3, I get 1.5, and then divide by 1. My height is just 1.5 feet. So X is equal to 1.5 feet. That's my height, okay? Or my width, however you, or my length, whichever one you want to look at it, okay? Then if I do my width next, I'm going to do the same thing. And it's the same scale, so you're still going to know that 1 inch represents 0.5 feet. Okay, but this time my width of this sign up above here says it's 2 inches long. So 2 inches is going to go on top over, I'm going to figure out what my actual width is of that sign. Okay, I solve it the same way. Cross multiply and divide. So I'm going to do 0.5 times 2 is equal to 1 times X, or I'm going to do 0.5 times 2 divided by 1. It's the same way. 0.5 times 2 is actually 1. And then I'm going to do 1 divided by 1. Well, 1 divided by 1 is just 1. So I know that my width is 1 foot. But remember, it didn't just ask for the length and the width. It asked for the area. So these numbers that I found, I'm going to plug into my area and figure out what the actual area of that sign is. So if I plug in this information, area will then be equal to 1.5 was my length times 1, which was my width. When I do 1.5 times 1, my area of this sign is 1.5 feet. And that answers the question. You will have a question just like number 3 in your level 2 assignment on digits. So make sure that you are familiar with this, and if you need any help or explanation, don't hesitate to ask your teacher. Okay, I hope you are then able to do the activity today. It should be a drawing activity. And remember, don't hesitate to ask for help.